G'day, it's time to get energetic about energy. This jet has many types of energy: sound energy and heat energy of the engine, light energy of the exhaust flame. Kinetic energy, that's the energy of objects that move. And gravitational potential energy, that's the energy of objects that fall down because of the pull of Earth's gravity or rise up against Earth's gravity. Today we'll learn the maths of the last two types, kinetic energy and gravitational potential energy. This athlete has a mass of 70 kilograms. She runs at a speed of 9 meters per second. How much kinetic energy does she have when she runs? The rule for kinetic or moving energy has two parts, mass and speed. Speed is also called the velocity. The rule for kinetic energy is equal to 1/2 multiplied by the mass multiplied by the speed or velocity squared. We will substitute the numbers into the rule. 1/2 or 0.5 is multiplied by the athlete's mass of 70 kilograms. This is multiplied by her speed or velocity of 9 that is raised to the exponent of 2. The answer is 2,835 joules. Joules is a measure of energy. To put this in perspective, eating 1 bar of chocolate gives a person about 1,000 joules of energy. So this athlete uses the energy of nearly 3 chocolate bars during this race. This boxer moves his fist to punch the bag. His fist has a mass of 1 kilogram. The speed of his punch is 5 meters per second. How much energy is used for just one punch? Here is the kinetic energy rule. 1/2 or 0.5 is multiplied by the mass of 1 kilogram and is multiplied by 5 squared. So one punch uses 12.5 joules of energy. Let's put this in perspective. If a chocolate bar has about 1,000 joules of energy, this man could burn off the energy of one chocolate bar after about 80 punches. Now let's consider the kinetic energy of this 10-ton jet flying at a speed of 1,000 kilometers per hour. That's about 278 meters per second. Here is the kinetic energy rule. 1/2 is 0.5. In this rule, we write the mass in kilograms. So 10 tons is 10,000 kilograms. We also write the speed or velocity in meters per second. So 1,000 kilometers per hour is about 278 meters per second. And then we square that number. The kinetic energy of this jet is an enormous 386,420,000 joules. Now let's learn the rule for gravitational potential energy. At the gym, a man lifts a weight that has a mass of 100 kilograms to a height of 2 meters. How much gravitational potential energy does this weight have at the top of his lift? The rule for gravitational potential energy has 3 parts. First, the weight has a mass of 100 kilograms. Next, the weight is being lifted upwards to overcome the force of gravity that pulls the weight downwards towards the Earth. Gravitational acceleration on planet Earth is 9.8 meters per second squared. Thirdly, the weight is lifted up 2 meters. We multiply these to get the answer that it takes 1,960 joules of energy to lift this weight up to a height of 2 meters. So this man uses the energy of nearly 2 chocolate bars in just one lift. In our last example of gravitational potential energy, let's consider the awesome energy of nature. The amount of water that is in an Olympic swimming pool, that's 2.5 million litres with a mass of 2.5 million kilograms, goes over this waterfall every day. The waterfall is 60 metres high. How much gravitational potential energy is there at the top of the waterfall? The mass is 2,500,000 kilograms. The gravitational acceleration on Earth is 9.8 meters per second squared. The fall is 60 meters. So the energy of this waterfall is 1,470,000,000 joules. That's about 1.5 billion joules of energy every day.